This video covers congruent figures, so we're going to recognize congruent figures and their corresponding parts. Congruent polygons have congruent corresponding parts, and corresponding parts just means that they're in the same position. So when you name congruent polygons, you must list corresponding vertices in the same order. So if you look at the two polygons we have here, the left is listed A, B, C, D. So AB is in the same corresponding position as E, F, G, H, E, F. And if I continue around, BC, FG, CD, GH, and lastly DA, HE. So those are all in corresponding locations. In our first example, it says if JKLM is congruent to NOPQ, what are the congruent corresponding parts? So you can either do it by looking at the diagram or just by using the congruency statement. I personally think it's easiest just to use the congruency statement. So starting off, side JK and NO would be congruent. And we can highlight those the same color just to help us know which sides we've already done. So JK, NO. Then next, I would have KL, OP. So KL is congruent to OP. Next, LM, PQ. So again, I'm just going through my congruency statement and I am going in the corresponding orders. And last set of congruent sides would be MJ and then QN. Then I want to list the corresponding angles. So remember, we're just going to name these angles with one letter. So if I look at my congruency statement again, I'm just going to go directly in order. So I have J and N. So angle J congruent to angle N. The next one, K and O. Angle K is congruent to angle O. LP. Angle L is congruent to angle P. And lastly, MQ. Angle M is congruent to angle Q. The third angles theorem states if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. If I fill in some measurements for you, just so that you have an example and it makes a little more sense. Let's say this angle B is 60 degrees. That means that E is also 60 degrees because they're marked congruent with the same number of tick marks. Let's say that A is 50 degrees. That means D is also 50 degrees because they're marked congruent. And using our knowledge of triangles, we know that triangles add up to be 180 degrees. And so if I add these together, I get 110. 180 minus 110 is 70, which would make my remaining angle 70 degrees. Again, that doesn't look like 70 degrees, but I just made up an example. And remember, we go off of our math, not the diagram. And if I did the same thing with this triangle DEF, I'd get the exact same answer. So again, the third angles would be congruent. If we're going to prove the third angle theorem, we always start with our given information. So given that angle A is congruent to angle D, angle B is congruent to angle E. One thing that's going to start happening soon in geometry is that we're going to have to mark our figures. So if it says angle A is congruent to angle D, we want to double check that it's already marked in the figure. And since it is, we don't have to add those marks this time, but just be aware very soon we might have to. Now, I know that I'm going to have to start adding some measurements very soon. And when we talk about measurements, we have to be using equality and not congruence. So really quickly, I'm just going to switch these statements to be equality. So if they're congruent, I know that their measures are equal. And we know that because that's the definition of congruence. Now that I've used my givens, I've switched those over to equality. I need to start looking at my diagram for some information. So I know that the angles of a triangle add up to be 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. Also, the measure of angle D plus the measure of angle E plus the measure of angle F equals 180. And we know this because triangle, angle, sum theorem. Now, hopefully you're starting to pick up on some patterns, but really similar to last proof that we did yesterday. I have A is equal to B. B is equal to C. So A is equal to C. So that's that transitive property. So I write out the measure of A plus the measure of B plus the measure of C equals the measure of D plus the measure of E plus the measure of F, transitive property. Now, if you look back up to our second line here, we have some things that are equal to each other. So we have A equals D. So anywhere I see an angle A, I could replace with an angle D. Same thing, I have an angle B equal to angle E. So if I see a B, I could replace it with an E. So I'm going to do that now. So again, D gets plugged in for A. E gets plugged in for B. Everything else I'm just going to rewrite. When we plug things in, we call that substitution. Now, if you look on both sides of this crazy long equation, I have some matching items. I have matching measure of angle D's and measure of angle E's. If I wanted to remove those, I would subtract them from both sides and that would cause them to cancel out. So then I would be left with the measure of angle C equals the measure of angle F, subtraction, property of equality. And now we are really close to finishing this proof. These almost match. The only difference is I'm currently in equality and I want to be in congruence. Remember, it's really easy to switch back and forth between the two because they really mean the same thing. So if the measure of angle C equals the measure of angle F, then C is congruent to F because that's the definition of congruence. And now we have proved the third angle theorem. For your remote assignment, you are going to do the worksheet that was given to you in class. that will be due when you return to class next. So just make sure you have that completed. Reach out to your teacher if you have any questions.